Our first speaker for the session will be Friederike. Friederike is working for HySpex Neo as a geological hyperspectral application specialist. Good grief. Where she is applying hyperspectral imagery to help miners mitigate risk, unlock value, and save time. Norsk Elektro Optikk AS, a HySpex division, is the industry-leading brand for both airborne and ground-based hyperspectral imaging and manufacturing of advanced electro-optic products. Friederike wrote her doctoral thesis on superspectral copper ore detection and implementing hyperspectral data and instruments in open-pit mining environments. Fantastic. Look forward to it.
Great. Thank you so much for the introduction. And my name is Friederike Koerting. I'm working for HySpex. I've worked with a couple of people in the room already, so I'm really happy to be here today. It's my first time at GRSG, so I'm excited. Yeah, we're talking about multi-scale and multi-sensor mapping for tailings management today, a little bit about MinePhase as well, and it focuses a lot on a current European Union funded project that HySpex is a partner of, which is M4Mining. So we're going to talk a little bit about that as well. And as you can see, we have a great bunch of partners in there, and we're all involved in that project. I'm just going to look a little bit more at the HySpex side of things. See if the slides are working. Yeah. So I think most of you will be familiar with the general challenges that we're trying to address here. We're looking more at base metal mining in general and the different challenges associated to that. And one of the first challenges that comes to mind is that for the new green technology, of course, in our green transition, we need a lot of metals in the next couple of decades. Up to 40% or 40 times, sorry, more lithium, 20 times more nickel, cobalt. All of that is not new. I think we're all familiar with that fact. The same goes with that mining is actually changing our land surface quite a bit. We see a lot of impact from that, both in environmental context as well as land disturbances and waste. So the majority of metallic ores are mined with surface methods, and we can see them quite well with remote sensing. So that's one of the potentials that we see here. And for Europe in special, and why the call from the EU was open for that, is that we see that Europe already has quite a bit of mine wastes that are deposited across of Europe, and that's both for mine waste and for tailings. And while we see an increasing demand for raw materials, we will also see an increasing demand of monitoring and actually managing those resources and waste. And as I said, Earth observation technology from the MinePhase scale to the chem scale to a larger regional scale and deposit scale are actually have quite a potential to actually solve some of these problems, or at least monitor them. And that's what we're looking at in the next couple of slides and in that project. Most of you will be familiar with this, but I just wanted to give a general overview of where remote sensing research has actually included or intersected with mining, and especially not only with exploration, but a lot with open pit mining in that case. We have a lot of surface mineralogy and lithology in different deposit types, and a lot of research that happened there. We focused on carbonatites in the last couple of decades, and the community has looked a lot at porphyry deposits and epithermal gold and silver and skarn deposits, as well as limestone aggregates, for example, if you look at non-metallic ores in that case. But based on some reviews, we see that there's understudied deposits as well. And those are more in the nickel sulfide, chromite, uranium, even iron ore side. And on the detection and monitoring side, we see that illegal mining, gas emissions, land cover changes, settlement, and then rehabilitation efforts and reforestation has been tackled. But a focus of this research that has actually been applied within mining and within the industry, or the industry uptake, has been concentrated on greenfield and brownfield exploration. We don't see a lot of it making its way into mining as a standard method, or at least into extractive mining as a standard method. So we see a lot of it being applied for exploration, and that includes the drill core scanning with a higher resolution data. Yeah, so how do UAVs and mining actually connect to that? We have a couple of hyperspectral UAVs that are being used or that are being deployed, and HySpex has one of those. but we don't see hyperspectral, especially in the visible to near and shortwave infrared, being applied a lot for mining right now, or within mining. And most of the UAVs that are being used in mining environments are small scale RGB sensors, maybe LiDAR. We're looking at stability assessment and geophysical surveying with larger UAV systems. We're looking at ground subsidence and post-mining monitoring, but less so mineral mapping or anything that goes into a proper block modeling or even waste monitoring. And that brings me to the objectives of M4Mining and the project in general. And with a focus on what HySpex is doing currently, we are developing a UAV platform that is optimized and dedicated for mining environments. That includes the sensor, but it includes the whole chain behind that and the whole hardware software solutions that we're trying to tackle here. So we want to enable oblique UAV-based scanning of steep vertical mine faces as well, on top of the nadir scanning, that is a typical method. And we all know that there's a lot of challenges associated to that, especially for atmospheric correction or even for geometric correction. On top of that hardware and software development, we're also trying to provide best practice for miners and for non-experts in the field to give guidance for hyperspectral UAV surveys for operators. And that includes validation and sampling and proper auxiliary data that needs to be collected. Especially because mining validation means something different than remote sensing validation, right? Just as a point here, there's some connection, but it's not the same thing. And yeah, I just wanted to point out the main areas that we want to look at and that we're optimizing the UAV system for. So we're looking at larger scale tailings and mine waste monitoring. So we want to be able to cover large areas. We want to look at reclaiming and remining of tailings, at the monitoring of surface processes, obviously, and in general aiding environmental impact studies. And there has been a lot of work in AMD detection, but again, this hasn't been applied in the industry as a standard yet. And we see that we need to actually change or at least contribute to those standards with more remote sensing work. Yeah, on top of the tailings and mine waste, we actually want to look at the run of mines. So that's why we're trying to figure out how to deal with oblique scanning in steep terrains where we might lose GPS. So we have partners in the project that are looking at autonomous flight planning and general flight planning that is in compliance with how mining operations work. So that's going to be a big topic for us. And it's going to build into a close-to-face sorting or even scanning after blasting. So we're trying to figure out how to integrate and make sure that the UAV actually contributes to that. And I already mentioned that a little bit, but apart from A&D detection and mining, we of course can contribute to slope stability as well. And we can detect mineral surface changes as a proxy for any kind of contribution that comes from the subsurface in that case. And this might also be very valuable for stockpile monitoring, especially when we talk about large areas that we're trying to monitor consistently. And we're currently at the point where with the different partners that we have in the project, where we are looking into creating relevant data products that are easy to read, interpret, and integrate within mining, but also for geologists that are not usually spectral geologists. So if anyone has any comments on that in the coffee breaks, I'm happy to hear them, because we are currently looking at existing literature. We're looking at existing data products and existing algorithms, and we're trying to compare them based on accuracy and scalability between UAV and also satellite data products, but also in context with the actual value to miners, the integration and export into different typical mining software and modeling software, and an actual data product demand from real time to near real time. Yeah, so this is the drone system that we're speaking of. That's the current system from HySpex, which is the Mjolnir VS620. This currently runs at a nadir capacity, so we're not looking sideways yet, but this is what we're working with and that we're adjusting. And we have a payload of around 6 kilos. Currently, the total takeoff weight is below 25 kilos, as with current standards in legislation, to actually enable flying a little bit or be more compliant with easier pilot training. I think that's the main point here. And this is our camera, the Mjolnir VS620. We also have that just for the Vini or just for the sphere, depending on what kind of application you're focusing on. But this one combines 400 to 2,500 nanometers in that project as well. So we're trying to get iron oxides, but also different clay and alteration mineralogy. We have a LiDAR on board, we have an RGB camera on board, and then we have all of the auxiliary hardware on board that is necessary to actually make that a viable option to fly in difficult terrain, which I'm not the expert in that. So if you would need like burning questions for that, ask Trond, he's in the back, he knows best. Yeah, what we're also doing currently is assessing the current operational environments of this drone and how we need to adjust it to be operational under a large range of different environments, and that's temperature, but also altitude is a big topic when we think about open pit mining in Latin America. We're assessing the takeoff weight because legislation has just changed, so we might be able to fly above 25 kilos and have more batteries or even longer flight times, which is a big thing for really large areas. Our current goal is 3 to 5 flights per day and up to 20 minutes flight time with this current system, but that can be extended on if it's possible to fly a heavier drone and have more batteries on board. And we're assessing different real-time and non-real-time requirements for different data products, but also processing. And with near real-time, we are planning to have high quality or final data products available after 4 hours. And we have a mineral advisory board in the project, so we're discussing with them what kind of real-time requirements we're actually needing and what is necessary to see while we are flying and what's necessary to see right after we're landing. Yeah, just a little bit about the project. So we develop most of the hardware and software within Europe. It's an EU-funded project, and we have partners in Sweden, Greece, Germany, Norway, and Cyprus. But most of the specialized UAV infrastructure and platform is developed at HySpex in Norway, and we have frequent testing of the infrastructure and hardware design there as well. To enable real-time data collection, access, and processing workflows, we're working with partners from Sweden, Norway, and Switzerland, and most of you might be familiar with RESE and the ATCO and RUATCO software, so they are partners in that project to enable this actually, to enable oblique scanning and correction of data. And then we have one partner, Australia, as well as the University of Queensland, and they help us establish best practices and standards for using hyperspectral data, drone data, and also the upscaling, downscaling from satellite to UAV data together with a GSZ in Germany. We have a couple of different case study sites around the world. We have some in Queensland and some in Europe, and these are being used to test both nadir and oblique scanning. We just had our first flight campaign, so the project started in January 2023. And we just did our first case study in Australia in September in a mine, and I'm going to show you some very preliminary data from that. But yeah, most of the case study sites are in the Mediterranean. So we have a tailing from copper gold mining in the Nicosia district in Cyprus, where we see a lot of different very small scale mining, which is why we're tackling it more with the UAV applications, just for pixel size and scale, so that we have the proper spatial resolution of around 10 centimeters, as opposed to 10, 20, 30 meters. And this one is a legacy mine site from, I think it finished, yeah, in 1990. And we're characterizing waste mineralogy and waste management. And Cyprus is quite good at doing that because they have copper mines from centuries ago. So they see a lot of mine waste, and we see a lot of alteration on the surface. And then in Greece, we have 2 different mine sites that we are going to look at next year, which is an active bauxite mine that operated until 1965. And we have a clay mineral, no, it's in operation, sorry, since 1965, it's active. So we're looking both at the mine face as well as the tailings there. And then we have some industrial aggregates in clay mineral mining in Greece. And in Australia and Queensland, we are looking at different legacy mine sites. And the one that we looked at already is called Mary Kathleen, which is close to Mount Isa in northwestern Queensland. It's a former uranium deposit that has been active until 1982 and won a lot of prizes for best closure in the 1980s. So we're reassessing those plans, maybe. But we're having a look at it with the Geological Survey of Queensland and the University of Queensland as well. And it's a calcium skarn-hosted rare earth element uranium deposit, and they're now assessing it not only for monitoring of mine waste, but also for remining of the tailings storage facility, which is possibly rare earth element bearing. And just to, we're going into this just a little bit. And this has been funded by the European Union within M4Mining, but also by Auscope, with a lot of support from the University of Queensland. And what we're looking at here is, we had some, you can see the flight lines here, right? So we had a couple of UAV flights in the open pit with more steep terrain, but still nadir looking with our current system. And then we looked at just the junction between the tailing storage facility and the evaporation pond, and then the discharge of the evaporation pond. And we only looked at this data so far. We're currently in the process of looking this. So if you're planning to join the URSL workshop next year, then in Valencia, I think in April, then we might have some results on that to present. But yeah, both the tailing and the evaporation pond has been covered, and this is quite a large area. So this is very valuable to look at with satellite data, for example, with NMAP, what we are planning to do in the future as well. And for the open pit, we scanned the southern part of the open pit here because there's a fault line going through. So we know that we'll see more alteration towards the west. And we were interested in just scanning some of the mine faces just as an example of what mine face scanning from a UAV would look like. But this is still tripod based. And what we see, or what we know from this deposit, is we have a higher uranium concentration here. It's been mined towards sedimentary units, so we don't expect a lot of spectral activity there. And there's a discontinued calcite lens just in the center that will be cropping out towards the north and the south. And of course, we analyzed it with the USGS MICA classification. I'm not sure if I need to introduce it, but the MICA stands for Material Identification Characterization Algorithm, has been developed by the USGS and published on first, I think, 2011. And this is an expert system that is looking at mineralogy mostly. So here we're looking at surface mineralogy right now. And this is the scan of the open pit. This is the RGB from our HySpex system. And then we see quite a change of mineralogy, especially towards the more altered zones here. We see jarosite and possible oxidation happening, or at least we have more reactive surfaces down here. And you can see some of the calcite cropping out down here from discontinued lens, and then a little bit here. And this is where we mined towards sandstone, or where they mined towards sandstone. So we don't see a lot of clear patterns toward that side. And then we did the same with our open pit flight. And this is data that has been corrected a couple of days after the routine to be shown in a workshop in Brisbane. And what we can see here is that, of course, we are within skarn lithology, so we're in skarn deposits. So we see a lot of calcite or carbonates in general mapping out. And those are not the original spectral library names from the USGS. We just grouped them into sensical groups just to have a clearer picture of the color coding and the different changes on the surface. But yeah, we have a lot of activity here that's already visible in the RGB that is more mica-rich. And then towards the shear zone, we see that there's more kaolinite coming in, even though, or in general clay mineralogy, even though the shear zone is a little bit towards the west there. And we have another UAV data set that we're going to just investigate for that. But this has been compared to a paper from 2017 where HyMap data was acquired over the open pit. And it matches very well with what they mapped in terms of mineral patterns and geology. Yeah, and that's my presentation. So if you're interested in the project, have a look at the website. Have a look at HySpex if you're not familiar, but we're also here and I think you're familiar with it. So I'm just putting the website here just in case you forgot, and feel free to reach out to me